Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Let's step on inside and let's find the last method of solving quadratic equations that we're going to be dealing with outside of graphing them, of course, is using what's called the quadratic formula. Now, to recap, what we've done so far is we've solved by factoring and using the zero product property. We've solved by using square roots, provided that you have an isolated squared variable or a squared quantity. And then we solve by completing the square, where we factor something down to a squared quantity. And now we're going to use the quadratic formula. Now, solving by completing the square and the quadratic formula are the only two surefire ones where we can guarantee ourselves solving irrational solutions if they exist. Irrational meaning ones with square roots still inside of it. We might have to simplify radicals. Solving using square roots does that as well, but you can't always solve using square roots, provided that you're not, you don't just have an isolated squared quantity or variable. So completing the square and quadratic formula both do that. We've seen some of the pitfalls of solving by completing the square when it comes to having an odd linear coefficient, factoring a that's greater than 1, little things like that of that nature, but otherwise it's pretty beneficial. It has its merits and it can be very efficient depending on what kinds of problems that you are using to solve. But the quadratic formula is one that it has a fraction pre-created inside of it, and provided that it's already there and you don't have to do something like work a common denominator or anything like that, it's not too bad to work with. So some students, as long as they know the quadratic formula, they're pretty comfortable with it. Now I want to make you comfortable with it as well. Now I am going to provide a video down below also where I really first introduce the quadratic formula, probably in a deeper way than I will here, because here I want to do some practice problems with you guys. But I am going to break it down in a way where I do a lot more examples here that's probably more important for you to watch, I suppose, where we also evaluate what's called the discriminant, and we understand how solutions in there work. Either way, guys, it's kind of a bigger formula for you to know, and I guess memorize is the word. And then when you substitute in values, we're going to still work on simplifying radicals. We're going to work on simplifying the fractions within, and you'll kind of understand why sometimes solving using completing the square can be faster or more efficient, I suppose. If I do any other videos beyond this in this unit besides an overall review, it'll probably be one where we look at methods for solving, choosing which method to solve by factoring, quadratic formula, or completing the square, and why we might choose one versus the other. Either way, guys, quadratic formula, I've spent enough time doing an intro to this portion of this video. Let's go ahead and get into it. Now, in order for this all to work, guys, we need to know what the quadratic formula looks like, and the basic nature, of course, for the formula is we have to know what condition sets up the formula. And the condition is if we have a quadratic equation written in standard form and set equal to 0. So if ax squared plus bx plus c equals 0, and this is a must. This is a part of the idea of the formula. You need this set in standard form in this way, set equal to 0, so you know what a, b, and c represent. Then you can actually get x by itself, and I'm not going to do a whole proof with you on it right now, but then x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So here's the formula itself, the quadratic formula here. You can solve for your variable. You can solve for x or n or k or whatever it is. You can solve for those if you substitute your a, b, and c values into this formula and basically break it down. You compute things, simplify it, make sure you know your order of operations, things like that. And if you have irrational solutions, this thing's already set up for it. Like I said, this formula comes into play as a proof of completing the square and doing things like that. But there it is. There it is. Now, there's this thing inside the square root right here that's known as the discriminant. And I'm going to be working with the discriminant first and foremost, not just when we're doing quadratic formula problems, but the very first, I believe, 6 problems, I'm going to be asking you to find the discriminant itself. Now, the discriminant has a very specific tactic to it. It is the b squared minus 4ac. And it's called the discriminant because it discriminates against certain kinds of numbers, whether we're talking about positive numbers and whether those are perfect squares or not, whether we're talking about 0 and whether we're talking about negative numbers as well. When the discriminant b squared minus 4ac results in a positive value, you will actually get 2 solutions, two unique solutions to your answer. If your positive discriminant is a perfect square, and I should be writing this stuff down, but I'm just going to be saying them out loud right now. If you're, you know what, I'll go ahead and write them down. If you're b squared minus 4ac, if the discriminant is greater than 0, then you'll have two real solutions. If your discriminant is equal to 0, you'll have one real solution. And then if it's less than 0, you'll have no real solutions. They're not real solutions. There are things called imaginary solutions, which is something that I believe that for my students I'll dive into at in a later unit. For now I'll say no real solutions, but it is also two imaginary solutions. Right now we'll just state the fact that they're not real. I'm not going to dive deep into what the real or not real means. What it does mean is we'll stop the problem at that moment and we'll state, all right, no real solutions. We'll halt our process, because I didn't do any when talking about completing the square either. I avoided them. And I don't believe that we're going to be playing with no real solution problems in here outside of testing them in the discriminant. Now, there's one other portion that I'm going to be referring to is when they're positive perfect squares, they are rational solutions. That also means that they're factorable. You could have solved it by factoring. There, you can take the square root of it. And really, excuse me, let me pause my video for a second. Let me take a hit of water. Okay, I'm back. You didn't miss a thing. All right, anyway. There's a reason why these things occur. And the idea has to do with taking the square root of this value. You see, when we take the square root of a positive number, we get a positive number out. And then we add or subtract that number. So if you add the number or subtract the number, you're going to get two different values. And that's what happens, whether it's rational or irrational. You'll get two solutions. When it's 0 and when you take the square root of 0, you're not adding or subtracting anything to it. So, there's only just the one answer. That'll be this negative b over 2a. And then when it's less than 0, you're taking the square root of a negative. And there's a way to take square roots of negatives. That's the imaginary solutions, but we aren't going to be dealing with those here. Okay, guys, let's find the discriminant of each quadratic equation. Basically, I'm going to be doing the b squared minus 4ac. That's all I'm going to be doing. And then we're going to state the number and type of solutions, how many solutions and what kinds they are. What kinds they are. Okay, so in order to do this, once again, you have to first make sure that you have your equation in standard form and set equal to 0. If it's not, then you don't truly have your A, B, and C. Another thing about this, if they show up, is I'm going to make sure that I have an A that's positive. Just trust me on it. It's going to be a lot more helpful in the long run. And really, what I'm just going to state is put it in standard form, and my idea of standard form for us is going to be if there's something to factor, like a leading term that's negative. Oh, also find a greatest common factor if it exists. But if there's a negative leading term, factor that out. So we're in standard form here. We have 7n squared plus 8n plus 1 equals 0. What that tells me is that the a value is 7, the b value is 8, and the c value is 1. This is nice because when I evaluate this discriminant right here, we're going to be doing b squared minus 4ac. And that will be 8 squared minus 4 times 7 times 1. So that discriminant is 64 minus 28, which is 36. So that number 36, it is a positive value. 36 is greater than 0, obviously. It's a positive value. And a positive discriminant means you'll have two real solutions. So there are two solutions, but furthermore, it's also a perfect square value. So these are two rational solutions. Rational and irrational numbers are all real. They're all real numbers, but because it's a perfect square, they're real rational solutions. That just means that you can take the square root of that number and you can break it down into an integer or fraction answer without a radical in the way. All right, number 2. 4k squared plus 12k plus 9 equals 0. One more time, this is in standard form. There are no common factors. That means that a in this case is 4, b is 12, and c is 9. So when we do the discriminant here, that's going to be b squared minus 4ac. So that is 144 minus And then I have 16 times 9, and actually I think that's 144 as well. So 144 minus 144 is 0. Now 0, taking the square root of 0 would lead you to just one solution. That is a 1 real solution there. It would also be a rational solution as well. I should probably put rational. I think it's probably more important for me to just talk about real versus non-real. If you just say real here, that's totally cool. I'm mentioning rational just so you understand that if you get a perfect, I guess 0 is a perfect square, right? 0 squared. But if you get a perfect square in here, that also means your thing was factorable. That's something I'm probably going to bring up at some other point. That's why I'm bringing it up now. All right, number 3. Once again, we are in standard form here, set equal to 0, and that's all too important. So the a value is 7, the b value is 3, and the c value is negative 2. Negative 2. So when we do the discriminant here, we're going to be doing b squared minus 4ac. Now the c once again is negative, and that's too important. We have to make sure we recognize that. It's something that's lost on students sometimes. 3 squared is 9. Now we're going to be doing minus and negative here. That does turn into plus. Keep that in mind right there. 4 times 7 is 28. Doubled is 56. So we have 9 plus 56. And that is 65. Now 65 is a positive number, so it's a real solution. It's real, but it's irrational, just so you know. It's two real solutions. So we're going to have 2 real but irrational solutions. That just means that, you can't take the square root of it. It can't even simplify, but it's not a perfect square. They are real, though. They are real, but irrational. All right, number 4, x squared plus 4 equals negative 7. Now, this is not in standard form set equal to 0. This is set equal to negative 7. So if I add 7 to both sides, I can combine it with the 4, and I get x squared plus 11 equals 0. It's in standard form, but it's a quadratic binomial. We seem to be missing a term. If you think about this, we're missing the term with the x in it. This would be x squared plus 0x plus 11 equals 0. Not a requirement for you to write, but it is a requirement for you to know that when you identify what a, b, and c are, that first of all, a, you guys know what a is? A is 1, right? You can't see that 1 there, but a is a positive 1. B is 0. And C is 11. So, just to kind of make sure you note what those things are, and if you need to write it out that way, go ahead. But you don't know A, B, and C until or unless you get it set equal to 0. If it's set equal to negative 7, forget about it. You're not using quadratic formula or discriminant stuff. Make sure you first identify that. But our discriminant here, let's take a look at this one. This will be B squared minus 4AC, like that. And that'll be... hold on, I'm checking something. Okay, and that'll be 0 minus 44, which is negative 44. So negative 44, a little different there. We have a negative. Doesn't matter if this is a perfect square. It's not a perfect square anymore. Once it's negative, it's not. But it doesn't matter if this looks like negative 25 or something. Once it's negative, and you did the math right, you have no real solutions. No real solution right there. 2 imaginary solutions, but we'll dive into that on a different day with my kiddos. Just kind of remember that Mr. Robinson stated that there. All right, number 5, let's get this thing into standard form. Now, as far as that goes, I kind of mentioned that I like the a value being a positive number. So you have 2 options. You can either move these things over to the left side and factor the negative 1 out. So I can add 6x, subtract 1, and then if I factor a negative, if I divide both sides by negative 1, if I change all of my signs here, which is really a thing that you'd want to do, it's still set equal to 0 here. Your solution sets don't change. Mr. Robinson, what did you just do? I divided everything by negative 1. I multiplied everything by negative 1. I changed all my signs. That's allowed in an equation. Whatever you do to one side, you can do to the other. I did this to make my a value positive for the sake of quadratic formula and everything else that we do in factoring, just in factoring in general. It's really, really, really recommended that you always just do that. You get your leading term positive in an equation, not an expression, but in an equation. Get that leading term positive. So you can do it that way. Or I could have added 9x squared to the right side, which is probably what you'd see me do more of because that was one step and didn't have to change signs. I just had to change parts of the equation. But if you add 9x squared to both sides, see you get the negative 6x and the positive 1 set equal to 0. Anyway, a is 9, b is negative 6, and c is 1. Now, negative 6 in the discriminant, when I square a negative 6, it looks like it'll turn positive. Don't forget that. Put it in parentheses to be sure. Minus 4ac here. That's going to be a positive 36 minus, looks like a 36, so we're getting 0 another time there. And that's 1. That's one real rational solution. Okay. And lastly, on number 6 here, with the discriminant, and you're wondering, Mr. Robinson, you haven't started quadratic formula yet. Yeah, we'll get to it. We're going to do discriminants on these. I want you to know what to anticipate for these. And sometimes I could just ask you how many solutions would be in it, and just practice your discriminant. Make sure you got that one taken care of first. Same kind of thing here, guys. I got that negative 10x squared. Why don't we go ahead and add it over this time? Add the 10x squared over to make it positive. Add the 1 over and set it equal all to 0. So plus 1 plus 10x squared. I'm in standard form. Set equal to 0. No common factors. We didn't run into any during this time. The a value is 10, b is negative 11, and c is 1. Is it required for you to write all this stuff here? No. I think it's a good habit for me to have you still do, just to make sure that you have the signs correct and things like that. You can plug in right from here. You know where a 1 exists or a 0. So your discriminant here is b squared minus 4ac. And that's going to be 121 minus 40, which is 71. 71, great. 81. 81, it's a positive number. Oh, and it's a perfect square. So that is 2 real rational solutions. But really, if you just state real, that's totally cool. You get 2 solutions. Okay, so the discriminant applies to every single thing here, guys. In quadratic formula, let me go and copy and paste this formula for us down below. But for the quadratic formula here, we are using the discriminant as a part of it. And what I recommend for you, and it's kind of funny that I say this because when I grew up, I didn't do this. If I do this on my own, I don't do it. So I don't practice what I preach, and it's probably a bad example and a bad idea. But when I teach, I do it. What I recommend that when you do these and you solve using the quadratic formula here is that you evaluate the discriminant first. If you notice, the advantages to it can be that you are really focused on the numbers as they are when you work in the calculations. You know how many solutions there will be and what kind, and you're really feeling it for what it is. You know what it's doing in the problem. It's part of... If you know b squared minus 4ac as its own little cluster, if you group it on its own merits, it makes the quadratic formula a little easier to remember as well. There's this whole negative b over 2a portion, and then that b squared minus 4ac is just another part. So it doesn't feel like one huge cluster. You've kind of chunked it in different parts. There are little advantages to it, and I'm going to keep in mind what they all are. All right, so number 7 right here. We have solved the equation with the quadratic formula, and I have this equation right here. Now, it is in standard form. It's set equal to 0. There's no problem with jumping straight into this and setting a, b, and c and, doing the discriminant thing like I recommended. But you do have a common factor of 3. And in any such problem, when you're trying to solve, it's always recommended that you work with that. I would factor a 3 out. From here on out, I'm just going to... hold on a second, I screwed up. From here on out, though, I'll just divide everything by 3. But I'm going to do that in a moment here. Plus n minus 1 equals 0. Okay, so when you divide both sides by 3 there, it's gone. It goes away. So we have 2n squared plus n minus 1 equals 0. Okay, we're going to solve this equation. We're going to solve what n equals with the quadratic formula. So there's going to be this whole n, instead of x equals, it's going to be n equals. N equals negative b plus or minus da 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 da. Now the b squared minus 4ac is a part of it. So if you'll indulge me, guys, I'm going to go ahead and establish what a, b, and c are. I'm going to start with the discriminant right here. And we'll get b squared minus 4ac, like this. That's going to be 1. Negative times negative is a positive. So that's 1 plus 8, which is 9. Now, 9 lets you know right now, guys, that we are going to get 2 solutions, and 9 being a perfect square means you also know there'll be rational solutions. We're going to be taking the square root of 9 inside this quadratic formula, right? That's what's going to be happening here. So let's try that. N equals, here's our b. So we have negative b plus or minus the square root of, now you don't have to plug this part in, you just did it right here. This is b squared minus 4ac. Of b squared minus 4ac, all divided by 2, a is 2. 2a, like that. Okay? So n equals, so opposite of 1's negative 1. Negative 1 plus or minus, that's 3. Square root of 9 is 3, all divided by 4. Okay, so we're going to be doing negative 1 plus 3 divided by 4. We're also going to be doing negative 1 minus 3 divided by 4. Like that. So negative 1 plus 3 is 2, and that's 2/4, which is 1/2. Or negative 1 minus 3 is negative 4 divided by 4 is negative 1. And those are our two answers there. So pause for a moment as you write things down. You can obviously pause me. Some things to think about with this problem. As I've mentioned before, this was factorable. I state that it was factorable because we had a perfect square here, then we had a rational solution. So this was possible to factor. If you think that this was an overly daunting task to kind of work all this stuff out and you wanted to try the factorization, I mean, this would factor to what? Plus 1 minus 1 like that, and then you could solve zero product property. 2n minus 1 equals 0, so n is 1/2. And plus 1 equals 0, so n is negative 1. That's a lot faster. I mean, it was a lot faster. It was a lot faster if you know how to factor given that 2n thing there. And obviously finding the common factor definitely helped here. I wouldn't have wanted to solve by completing the square for a multitude of reasons, the a being greater than 1, things like that. So if this was an irrational solution, quadratic formula is there. But you know what? It's totally valid. This thing's going to work. And it's good practice. You'll feel out which times you want to use it, which times you don't. Okay, let's go to number 8 here. 6x squared plus 8x minus 39 equals x minus 6. Now this is not quite our standard form we're looking for here. We need to set this equal to 0. I'm going to subtract x to this side. I'm going to add 6 to this side. And I have it equal to 0. This is, let me move my face. This is in standard form set equal to 0. There is no greatest common factor here, so we're going to deal with the cards that we have right now. So I'm going to go ahead and solve. We're going to set a equal to 6, b equal to 7, and c equal to negative 33. And, you know, once again, I'm going to go into the discriminant thing. If you want to argue that you want to plug some things in here, let me kind of still give you another counter against that. There are going to be times we're going to be simplifying radicals, and it makes more sense to simplify the radical on the side on your own. And also, this is where you do the majority of the work. If you think about it, with negative b, we're just changing the sign, and 2a, we're just doubling the number. Here's where we got to do like a little more work. So if you got to keep rewriting all this stuff to just do the discriminant portion and maybe simplify the radical, I think it's worth evaluating the discriminant on its own, at least when you first start doing this. And then if you decide you want to later just plug things in, then, you know, go ahead. But the discriminant is b squared minus 4ac, b squared minus 4ac. Okay, much bigger number there. Didn't anticipate that. So that's going to be 49, and you know, I don't know. I'm not mess that up. Let me whip out a calculator here. It's at 24 times 33. So that's 792. So 49, and that's a plus 792, right? Minus the negative. Plus 792, and that is, I don't even know that part, 841. All right, big number. Is there a square root to that thing? This is worth figuring out. There's a square root to that. It's, yeah, 29. Square root of 841 is 29. So we'll make sure to note that in our report. All right, quadratic formula here. X equals negative b plus or minus the square root of 841 all divided by 2a, all divided by 2 times 6 there. So x equals negative 7 plus or minus, what did I say was 29. 29 all divided by 12. So we're going to do x equals negative 7 plus 29 divided by 12, and x equals negative 7 minus 29 divided by 12. Split those things up. Now you want to do this when you have a rational set of solutions because you want to actually compute them. If there was a square root, there's nothing I could combine. I'd leave it in its plus or minus form right there. So negative 7 plus 29 is 22. And 22 over 12 reduces, divide top and bottom by 2, to 11 over 6. Negative 7 minus 29 divided by 12 is negative 36 divided by 12, which is negative 3. So those are your two answers there, 11/6 or negative 3. One more time, if this was rational solutions, that must mean that this was factorable right here. What would that factor to? Well, odd linear coefficient there means that's going to be 6x and x, maybe a plus or minus there. 33 is often like 3 and 11. To get to 7, I'm going to try the 3 here and the 11 there, so 18 minus, yeah, so it would be right here, 3, 11. This would be the minus, this would be the plus. So it would be like this right here, 6x minus 11 and x plus 3. So once again, if you know how to factor that fast, this would have been faster if you knew it was factorable. But here's the thing, you don't know it's factorable unless you try and factor, or unless you evaluate the discriminant and know that you have a perfect square value. So, if I didn't know it was factorable, maybe it's not worth digging in to try it. Maybe for you it is. I don't know. It's just kind of up to what you want to try. But anyway, it was factorable. Zero product property, you can get to the 11/6 and -3 that way as well. But we're solving using the quadratic formula, and we shall continue. We have 6 more problems to do, and, maybe they'll get a little faster, maybe not. I know that here we're probably going to deal with a lot more irrational solutions, and with them there are some things like simplifying radicals and things to play with. Give me one moment. Okay, here we go. All right, so number 9 here. Let's set it equal to 0. Let's add 6 to both sides, and I'll get 8a squared plus 12a minus 2 equals 0. If you notice, guys, we do have a common factor of 2. I'm going to just go ahead and divide everything by 2 outright. That's the whole divide everything by 2 like that. 0 over 2 is 0. And that's 4a squared plus 6a minus 1 equals 0. Automatically, to me, this doesn't look factorable because it just doesn't. I know my numbers. So that means we're going to have either irrational solutions or non-real solutions, and I think that these all have real solutions. So irrational solutions here. So let's jump into the discriminant portion of this. A is 6, A is 4, B is negative 6, C is... Excuse me. A is 4, B is 6, C is negative 1. It's hard to speak opposite of what I'm writing there. All right, so the discriminant right here. Here we go. We're going to get B squared minus 4AC. Keep in mind that C is a negative 1. So that's 36 plus 16, which is 52. Totally not a perfect square. But this is one of those moments, guys, that, we are going to have to do the square root of 52 at some point. So although the discriminant is 52, we are going to be taking the square root of 52 at some point. Let's go ahead and simplify that. That's 4 and 13. So root 4 times root 13 gives us 2 root 13. This is nice because when we do the quadratic formula portion inside here, we know that this is going to be the square root of b squared minus 4ac. I don't have to do more work on that part, Now, by the way, a is my variable. It's not an x. So a equals, so negative b, remember the formula, negative b plus or minus the square root. So this is negative b plus or minus, and here's the square root of b squared minus 4ac right there. So 2 root 13 all divided by 2a. And remember, I'm using this portion here because we divided everything by 2. So all divided by 2a. Not the same, not to confuse it with this a here. See, when you do a test or something like that, I make sure these are just x's. A equals negative 6 plus or minus 2 root 13 all over 8. Now, this would be the final answer, right? This would be correct, as in there are no like terms to combine up here, things like that. But, and this is the part that can tend to confuse people, but we do have a common, we can reduce the fraction. There's a common factor of 2 on top, which means these could all divide by 2. The 8 can divide by 2. You're trying to find out if these 3 numbers here can all divide, if they all have the greatest common factor as well, if you can reduce the fraction because of this. Because these are separate terms, you have to consider both of them. I can't just say, oh, 6/8 is 3/4 and I'm good. Likewise, this root 13 has nothing to do with it. Whether it's odd or even, doesn't matter. It's inside a square root. It's these numbers right here. And all 3 together can divide by 2. So if I divide these all by 2, I'll get a 3, a 1, and a 4. So this reduces to a equals negative 3 plus or minus the square root of 13, all divided by 4, like that. And that would be your final result, most simplified. Now, I would totally recommend solving this using quadratic formula. You couldn't factor it, and completing the square seems like it would bite, since you'd have to factor out that 4, especially from a 6, and that's no good. So quadratic formula is the best approach to it, but there are still just more little things to do there, reducing the fraction. And you can bet there's going to be more fraction reduction as I do the next 5 problems. Here and there, we're probably going to find them. All right, number 10. Negative 12m squared plus 12m plus 21 equals 0. Not only not only can I divide a 3 out of all of these, but I've also made mention of the fact that you really want that a to be a positive value. If there's one reason to make mention of wanting to have a be a positive value, imagine that the a was negative down here, and now suddenly we'd have a negative number, like that, right? One of the simplification rules is we don't have negative leading terms in denominators, or just negative denominators like that. So you'd have to be dealing with that negative as well. It's just not worth it. It's just not worth it, guys. So when I divide by 3, I'm going to be dividing by negative 3. I'm going to be switching the signs here as well. So this will become a positive 4m squared minus 4m minus 7. 4m squared minus 4m minus 7 equals 0. We're in standard form here. I don't know if it's factorable. It doesn't look like any factoring I've ever seen for it. I don't imagine that it is. But let's go ahead and do the discriminant, the whole discriminant aspect here. A is 4, B is negative 4, and C is negative 7. So the discriminant here will be in b squared minus 4ac will be a positive 16. Minus negative is a plus, and then 16 times 7, I think, is 112. Yeah, 112. So that's going to be 128. Now, 128 is reduce. You can simplify that radical. Okay, so that's going to root 128 there. I know you can divide it by 4. I think you can divide it by 16 because this was, well, actually, you can divide by 64. 64. So that's root 64 times root 2, which is 8 root 2. Okay, 8 root 2. So when we work on this thing, we're going to be dealing with a plus or minus 8 root 2 there. So check this out in quadratic formula. And remember, we're dealing with these for quadratic formula. M equals, now here's our negative b. Negative b is the opposite of negative 4. You might notice I've always been putting this in parentheses here, even with a positive number. Yeah, we're doing the opposite of this. It's not just negative 4, it's the opposite of it. So plus or minus, here's the square root of b squared minus 4ac, all divided by 2a. So that's going to be positive 4 plus or minus 8 root 2 all over 8. Now, as I mentioned before, guys, if you see something that can reduce this fraction here by dividing all of them by their greatest common factor, you do that. These can all divide by 4 together. So I divide this by 4, I get 1. Divide this by 4, I get 2, and 2. That reduces these. Again, this root 2 has nothing to do with it. That's not really a 2. It's the square root of 2, plus it's multiplying with that one right there, so we only reduce once with them. So anyway, so that all becomes m equals 1 plus or minus 2 root 2, all divided by 2. And that is your final set of answers there. And once again, that was irrational solutions, because this thing here, this wouldn't be terrible for completing the square. You'd still have to factor out a 4. Oh yeah, it would. You'd have an odd thing. Yeah, this is totally a quadratic formula worthy problem. I wouldn't solve it any other way, as far as preferred method, especially once I recognize it's not factorable. Man, I love to deal with these negatives with you guys, so, have fun. Looks like the 3 of the final 4 have negatives. Just me reinforcing once again that, work with those negatives when you can. So, I'll go ahead and I'll add the 6 over to start with. Plus 6, there's that. And then I'm going to divide everything by -1, change all the signs. I'll get n squared plus 10n minus 3 equals 0. Definitely not factorable. No two numbers multiply to make -3 and add to make 10. I can solve this by completing the square. And you know what? I'll show you completing the square as well, so you can kind of compare which you kind of like more when it comes to one that, this is very completing the square worthy, because it's a 1n squared and because that's an even linear coefficient. It's nice for completing the square, but I'll first do quadratic formula, of course. All right, so your A value is 1, B is 10, and C is -3. So let's start with the discriminant portion of this. So keep track of everything we do. This is now quadratic formula. In quadratic formula, discriminant here, we got B squared minus 4AC, which is 100, plus 12, which is 112. And that reduces to, so remember that was 16 times 7, right? We literally just did that up there. So that's 16 times 7, and that's 4 root 7. So that's what that simplifies to. So I'm getting a little black color blind here. Let's change the color. My bad on that. I don't mind keeping this part black, though, because that looks like a little side work. Discriminant's kind of side work as well, though, yeah? So here we go. Your whole thing, it's n equals, so negative b, so negative 10 plus or minus the square root, so 4 root 7, all divided by 2. If you don't mind, guys, 2 times 1 is 2, right? So boom, like that, all divided by 2. But here's the thing. These literally can all divide by 2. So, you know, when I reduce this one, divide by 2, divide by 2, and divide by 2, now everything's divided by 1. That means there's no more fraction involved. So now it's n equals just negative 5 plus or minus 2 root 7. I don't do anything else with that. There's no all divided by 1 because that's just a 1. And that would then be the final answer, as it's as simplified as I can possibly make it, right? So that's where it goes there. And that's not all the work in the world, right? That's not too bad. I would definitely argue that as long as you're doing the discriminant first and simplify before you do everything else, notice that I said 2 times 1 was 2 off the bat. You can really make these parts faster for yourself if you let some of the math, kind of take care of itself. That being said, quadratic formula still had a little something involved. Let's compare that with completing the square. Let me do a completing the square version because, of course, it's irrational solutions. Only completing the square or quadratic formula are the only 2 ways you can do it. As far as completing the square goes, remember this negative 3, it's got to go on the other side of the equation. We got to find something else that we got to add here. So 3 plus blank. We got to find the value that completes the square here. 10 divided by 2 is 5. 5 squared is 25. So I'm going to add 25 to both sides there. This factors to n plus 5 quantity squared, and that number is 28. Now I'll take the square root of both sides there, and I get n plus 5 equals plus or minus. Now root 28 is root 4 times root 7, so that's 2 root 7. And then subtract 5 from both sides, you get n is negative 5 plus or minus 2 root 7. So we still get the same answer here as we got there. I don't know which one you preferred more. You might argue that they're probably the same amount of steps. You might know this process a little more if you know the formula, plugging things in. But no, you did have to reduce a fraction. This was a larger radical that you had to simplify. And I don't know. It's just, it's just whatever you work on one versus the other. Completing the square probably has less outlets to work with when it comes to, like, you really want that to be a 1 and this to be an even. But at some point, I just want to show you that those are there. And I'm going to keep showing you those ones if they're worth doing. Like, I think number 14, I might be worth doing it there as well. But I'll save it when we get to it. All right, number 12. Number 12. Negative 4. Let me move myself here. Give me one moment. My mouse is kind of bugging. All right, here we go. Number 12. Negative 4x squared minus 12x equals 1. Hey, let's set it equal to 0. If you don't mind, I'm going to add the 4x squared and the 12x to this side. So 4x squared plus 12x plus 1 equals 0. Remember, it doesn't work unless you're set equal to 0 in standard form. No common greatest common factor, so we'll go ahead and work with this. A is 4, B is 12, C is 1. If you wanted me to show you another completing the square, I don't mind. Time is... You can fast forward me on that if you'd like to. Oh, you know what? Once again, I'm not going to do completing the square if I get an odd... I'm not going to do completing the square here. All right, so discriminant. B squared minus 4AC is 144 minus 16, which is 128. Did we do 128 before? Yeah, that was 8 root 2. So root 128, I'm going to save time. If you have numbers that you've already used, use them. Root 128 is 8 root 2. Not getting very unique, are we? Not very original here, huh? X equals negative b plus or minus the square root of b squared minus 4ac all over. If I wrote this as 2a, would you know what I just did? See, I'll save time by not writing, right? I mean, why should I put a set of parentheses here and 2 times 4 here if those are inner calculations that I can do pretty fast, right? If you can save yourself time and not write yourself an extra step, go ahead and do that. And that's once again why I do the discriminant first rather than later. I can divide all these things by 4 if I'm going to reduce fractions. And you know what? Fraction reduction is not a thing that happens all the time. I think I wanted my students to practice this so much. Divide these by 4, divide these by 4, that you really get into that comfort zone of doing it. So x equals -3 plus or minus 2 root 2 all over 2, like that. You're probably really uncomfortable and dissatisfied with these answers here as far as what they mean. And furthermore, we haven't plugged them into calculators before yet and approximated what they are, because I want you to practice the order of operations of them someday when we do more of them, I guess. But there are 2 answers there. I don't know what they are. I don't know what they're close to. It's probably close to, I don't know. But they are irrational solutions, and these are exact answers, and they're simplified. And that's what we're going for. That's what we're going for. All right, 2 more problems. Number 13, a to n squared equals 3. If I subtract 3 to both sides, I'm going to get a to n squared minus 3 equals 0. If you remember, guys, there's a missing middle term, right? So that's the b value that's missing. A is 8, but b is 0, and c is -3. So when we do the discriminant here, this would be b squared minus 4ac. Remember that negative there because we're going to get 0 plus, I think, 96. 32, yes, 96. 96 is a radical which we can simplify there. Square root of 96 is, I believe that's 16 times 6. Root 16 times root 6, which is 4 root 6. All right, let's go to work on that one, guys. N equals -b. B is 0. -0, what? Plus or minus the square root of b squared minus 4ac, all divided by 2a. Let me just write 2 times 8, because I got to do the 0 part anyway. So -0 is 0, and when you do 0 plus or minus something, what the hell, it's just plus or minus that something. So plus or minus 4 root 6 all over 16. Now the 4 over 16 can reduce to 1/4, 1 over 4. So 1 root 6 is just root 6, so that's n equals plus or minus root 6 over 4. And I am glad that I got one of these answers here as well, just kind of showing a different side of things. You might be wondering, Mr. Robinson, why aren't you reducing 6 over 4 to 3/2? Because that number's not 6. It's the square root of 6, which is just something. I don't know what it is. It's like 2.4 something, 2.45. I don't really know. But it's not a 6. And the square root of 3 over 2 is not the same thing as square root of 6 over 4. So you can't just reduce it that way. We reduce things outside of it. You divide reals with reals, and we multiply radicals with radicals and things like that. But those would be your final 2 answers there, plus or minus. So all these irrational solutions here. And finally, this one here, I'm going to add the 6n squared over it, and we'll get -1n squared plus 4n plus 13 equals 0. If I go ahead and swap the signs there for our own sake, we're going to get that right there, minus 13 equals 0. Looks non-factorable. This is good to solve with completing the square as well, right? I'll do completing the square with you on this one as well on top of quadratic formula. So if you see the quadratic formula 1 and that's all you want to do and you want to stop the video after, I'm totally cool with that. So the a value is 1, the b value is -4, and the c value is -13. So as we evaluate the discriminant here, we will get b squared minus 4ac, which is 16 plus 52, which is 68. 68 reduces to, I guess, 4 and 17. So root 68 is root 4 times root 17, so that's 2 root 17. Hope I didn't mess that up, and we'll look at the completing the square version as well. Let's check that out after. So let's see, what variable are we doing? N. So n equals -b. Now the b is a -4, right? No, wait, yes, the b is a -4, right? So what's the opposite of -4? +4. So 4 plus or minus, here's the square root of b squared minus 4ac, all divided by 2a. 2 times 1. 2. So as I reduce that, guys, all these can divide by 2, including, of course, the 2. So that'll be n equals 2 plus or minus 1 root 17, or square root of 17. That's the answer. Now, I just want to, so before I do the completing the square version, let me show you, what you might be doing. If you do the quadratic formula the way that it's, I'm not going to say the way that it's intended, but with you plugging things right into the formula before you do the discriminant and everything else, here's the work you'd be doing. You'd be saying like, okay, n equals, and you'd go negative b plus or minus the square root of b squared minus 4ac all divided by 2a. And then you'd be computing this part, right? You'd go like n equals, opposite of negative 4 is positive 4, plus or minus the square root. Now you're like 16 plus 52, all divided by 2. And that's 4 plus or minus the square root of 68, all divided by 2. And then you simplify that, and 4 plus or minus 2 root 17. So you're doing, you're doing a lot more work there, right? So that's why I'm having you turn away from doing that. The reason I do that is because I do a lot of work mentally. Hopefully at the cost of, or not at the cost of making a mistake, but I do a lot of work mentally, so I skip a lot of steps personally. I'll square 4 in my head and things like that. So I'm not really losing time when I do that. I think me writing discriminant, like I don't write A, B, and C. Like I don't do things like that, right? I know what they are when I'm doing them. But I'm doing this for your good health. Figure out which things you want to avoid. I like doing the discriminant portion for you guys though, because we like to talk about what this discriminant means, and it's your first time really working with this formula, so chunking it's good. Okay, completing the square. If I took n squared minus 4n and I added the 13 over to this side, I'm going to complete the square by dividing this by 2 and squaring it and adding that to both sides. This factors into n minus 2 quantity squared equals 17. I take the square root of both sides, so n minus 2 equals plus or minus root 17, and I add 2 over, you get n equals 2 plus or minus root 17. And that's solving by completing the square. You can see once again, if I did that pretty steadfast, but you can see here, once again, we didn't have to simplify that root 17, it kind of just becomes that root 17. The radical in here is always going to be larger than that one in completing the square, just for reasons. Because you're dividing by something in the quadratic formula there, and we're not doing it here. So, completing the square has its merits there. I just want to kind of confirm we got the same answer, and that there will be times when completing the square will be more beneficial, which is probably what my next video will talk about if we do a pros and cons list. All right, guys, so that'll do it for this one here. This was Mr. Robinson, and you learned the quadratic formula and some things within the discriminant as well. It may be a lot of work, maybe a little troublesome, but you can practice, and of course, there's no problem with getting a lot of practice in. That'll do it for this one, guys. This is Mr. Robinson. Thank you so much for watching, and take care.